to our virtual meetup. Today's topic is computer vision, something that I look forward to learning myself. I've heard a lot about computer vision. I don't know much what exactly it is, other than that it is some kind of deep learning. So that's why we are here today. We have with us Komal Devjani. Komal is with AlwaysAI. She was formerly a product manager, and right now she is a developer advocate who is a liaison between users, product, and engineering groups. Komal collects product, user, and industry data to drive product and feature implementations for AlwaysAI's computer vision AI platform. Komal represents the product vision to current and potential users at industry conferences and other tech events to acquire meaningful user insights and to drive greater product engagement. I'm going to also put in chat the website of AlwaysAI. It's alwaysai.co.com if you would like to look at what the company does while Komal is speaking. So Komal, thank you for doing this. We appreciate it, and take it away. Thank you.
Of course. Thank you so much, Pramod. Hey guys, happy to be here. As Pramod mentioned, I am a developer advocate at AlwaysAI. You'll hopefully learn a little bit more about computer vision by the end of this workshop, as well as a little bit more about AlwaysAI and how you can get started. I have a lot of interesting things planned for today's demonstration, but I'm going to start actually by sharing my screen. All right, so computer vision and AlwaysAI. So here's what I've planned for today. I just want to get into a quick introduction about what is computer vision, and then talk a little bit about common use cases of computer vision, and then we can talk a little bit after about AlwaysAI, our platform workflow and its various components. Then we'll discuss what is AlwaysAI and why we choose edge devices. And then finally, I'll get into like our website overview, how you can get started with documentation, our model catalog, blogs, and our YouTube channel if you're interested and you want to learn more. And then finally, I'll do a live demonstration for everyone here so you know exactly how computer vision works with AlwaysAI. And we're going to build and deploy a real-time object detector locally on my Mac Edge device. Okay. All right, so what is computer vision? And I think computer vision really is a part of the evolution of overall human vision. So, I mean, do you ever wonder how humans evolved to have vision? To me, it's like a beautiful concept. It started millions of years ago when small organisms developed a mutation that made them sensitive to light. Today, vision is the highest bandwidth sense we have. We need it to make our coffee in the morning, to read, to learn, to write, and to code. Our vision provides us with a fire hose of information about the state of the world we live in and how to act on it. So it makes sense that engineers, programmers, and academics have spent countless number of hours in the last half century trying to extend our intelligent sight to machines. We already know that cameras today can capture photographs with performance and fidelity that not only match the human eye, but exceed it. And in our changing world today, one of the things that will have a massive impact on our future is artificial intelligence, and most specifically, our ability to extend the functions of our visual cortex to matter. So with this technology, we're seeing the advent of things like the autonomous vehicle, auto-translate, and robots that clean our ocean, with use cases ranging anywhere from the agricultural industry to analyze grain quality, all the way to healthcare to identify cancer cells. The use cases of computer vision have great potential to maximize human productivity. So let's take a look at what some of the computer vision machine learning primitives are. So the first ML primitive, so these are what we call primitives, but you can call them APIs or functionalities. But it's essentially how computers can recognize and detect objects when they see them. So the first is image classification. In this instance, the input variable is an image, and image classification has the goal of being able to predict a set of labels and characterize the contents of an input image. So for example, you see this image A, right? In this image, a computer can classify whether it sees a bottle, a cup, or a cube. And then we have object detection. Object detection is a buildup of image classification, but this allows for the localization of each object within an image. So this can be available for a live video stream, and you want to be able to detect specific objects live. And this is characterized by a bounding box with XY coordinates for each object. And it has associated a class label for each bounding box. So as you can see here, every single object in this image is classified by a bounding box. And then we have semantic segmentation. So semantic segmentation algorithms require the association of every single pixel in an input image or video stream with a class label, including a class label for a background. So semantic segmentation algorithms are capable of labeling every single object in an image that they cannot differentiate between two objects of the same class. So semantic segmentation is one of the key primitives to get started with a autonomous vehicle. And then we have human pose estimation. So human pose estimation classifies various postures of a human body for gait analysis. So for example, right now we go to a bank with our masks on and we walk a certain way. So if there is security footage of the bank to recognize who it is and whether it is indeed Pramod who wanted to withdraw a huge amount of money, or whether it's me, they can recognize that by the movements of a person's body as opposed to just doing a facial detection. You can use this for fall detection. So this is really important for elder care. And the way you do that is by measuring how long it takes for a person to stand from falling. So if a person is standing and laying down, and if that time period between the two different pose estimations is short, like within a couple of milliseconds, then we consider that as fall. And then finally, it can be used for remote physical therapy. So right now in coronavirus, you're not able to go actually physically visit your physical therapist. There can be apps created to aid people in physical therapy and help them to identify how they're moving their body and whether it's for the right thing. Okay, and then other common use cases for computer vision include health. So that's robotic surgeons, fall detection, like I mentioned earlier, remote physical therapy, and then cancer identification and other disease diagnostics. Smart cities. So here we can see use cases of security, seeing if someone's behaving in a threatening way, traffic management, emergency services. This can be license plate detection to see if the Amber Alert message that's requesting people to identify a specific license plate, that can be identified in like an emergency service situation. Waste management, so determining the difference between glass to plastic, or determining the difference between cardboard and plastic, and then autonomous vehicles, of course. And then finally, we're looking at robotics and drones. So this can be industrial and manufacturing plants. So this can also tie back to waste management a little bit, but you can basically automate a lot of the work within an industrial plant with robots that use computer vision to identify how they should handle a specific material. There can be home care assistants, or robotic home care assistants. That includes elder care, pet care, child care, and rescue drones. So I've read so many articles about computer vision being used and deployed to drones to go and save surfers in Australia's coast, or going into the Pacific Coast Trail to identify hikers who might have been trapped in the trail. So that's a really common use case. But if you want to learn more, and I'll actually go through it a little bit later on when I review the website portion of AlwaysAI. If you want to learn more, you can always check out alwaysai.co/use cases. Now that brings us to the AlwaysAI platform. So the AlwaysAI platform, our goal is to essentially make the process of developing and deploying computer vision on edge devices easy and affordable. So it starts off with our starter apps and models. So these are starter applications that use pre-trained models from the AlwaysAI catalog, and you always have the option to build your own and upload your own models depending on what specific use case you're looking for. As of next month, actually, we'll also have training services available. So if you want the ability to train a model to support your specific use case, so for example, if you're looking to find plants in your garden and identify how to best care for those plants, and that model is not available, which it's not, I'm aware it's not, you can train a model to identify the plants in your garden and then train it to also identify how to best take care of it and deploy to an edge device. We have rich APIs that help you customize and extend your application. And when I go through the demo, I'll show you how you can go further into customizing your application and extending it to an edge device. And then finally, endpoints. So we have really user-friendly tooling that's optimized for the most popular edge devices. So we're talking about ARM32, ARM64 based edge devices like a Raspberry Pi or a NVIDIA Jetson Nano. And you can use that to build on drones, robots, whatever your use case may desire. So the workflow of the AlwaysAI platform is as follows. So all of the models and authorization to deploy to an edge device comes from our website, AlwaysAI. So what you'll do is register and then you'll download the CLI. And once that's available, this is going to be your development machine. When you've created your app in your development machine and you're ready to deploy, we use Docker to deploy your application to an edge device of your choosing. So it's like a 3-step process. What I'm going to do, because I'm not going to display this on a Raspberry Pi today, I'm only going to be running our models on a development machine. So I'm using my MacBook itself as the development machine. So, okay, let me just stop sharing this piece and then I'll get into our quick one-pagers. So really quick before I show you the website, as I mentioned earlier, right, you want to be able to develop your app in less than 5 minutes. You want to easily prototype and customize and configure and then quickly deploy to cameras, drones, robots, any ARM-based x86, which could be your PC or a Mac device. And swap models. So we support multiple different model frameworks, including TensorFlow, Caffe, PyTorch, or other edge hardware. So you can swap out your edge hardware, you can swap out models and try out various things really quickly, and then go from there and try it out. So as you can see, it's about 6 times faster to create and deploy, 10x more cost effective to run, and extremely flexible for all developers. And it really is a 5-step process. So you start with a pre-built starter app or a pre-trained model from our catalog and upload your own proprietary model. And I'll show you how you can do that on our website. You can customize and configure the apps using AlwaysAI's powerful abstraction layer. Use our CLI to deploy this to your workstation and a wide variety of edge devices. And then finally, we have model retraining, like I mentioned earlier, available next month. So you can train a model and essentially create a model to support any use case. Yeah, so from here, I'm going to take us to our AlwaysAI website and then just really quickly get into it. Okay, so here we are. When you get started, right, this is the first page you're going to see. So first, what I want to kind of do is take you through the use cases page if you're interested in learning more about or interested in getting inspired by some of the use cases some of our customers are using. You can take a look at this page. So you can see there's use cases ranging anywhere from healthcare, smart cities, robotics, marine industry, manufacturing, agriculture, waste management, security, smart home, marketing and retail, autonomous vehicles, and education. Okay, so now let's get into the meat of it. So let's get into the model catalog. So as you can see, these are our pre-trained models. So you can use our pre-trained models to build really powerful embedded applications with intelligent sites. So as you can see, we have all of the primitives available here. So semantic segmentation, human pose estimation, classification. And I'm going to show you the object detection models. So you go here, you view our models. Now, all right, imagine, before I show you all the models, imagine you went through this list and you found nothing that was going to be of value to you. So you can click here and you're like, okay, I see this, but I don't really want to identify a horse or a sheep or a cow because I don't have those things at home. I'd be very surprised if you do. And you go through it and you can see all the labels, all of the things that you're looking to identify, maybe a donut or a pizza or a cake if it's like a food app. Maybe this is going to be like a more of a smart cities application where you want to do some traffic management. So you can do person, bicycle, car, motorcycle, airplane, bus, train, truck, boat, traffic light, so on and so forth. Imagine none of these work for you. What you can do is you go up here and you can choose to upload your model. And here you specify every single detail that's required here. And once that's there, it's going to be available just for you. So it's not going to be a publicly available model, in case you're wondering. It's going to be available just for you, and you can use that to deploy to your workstation. Oh, sorry. So from here, let's go back to object detection. I'm going to show you the model I'm going to display for you. So we're going to do the SSD MobileNet. This is trained based on the COCO data set. So as you can see, the idea, of course, is like to make it really, really easy to deploy computer vision on edge devices. So we have these CLI commands available that you can use. But what I would do before that is, of course, sign up, make sure you have registered for the account, and then you go into your development computer setup. And depending on what you use, Windows or Mac, you will download this for Mac OS Catalina, Mac OS Mojave. Once you've done that, you will go into your CLI. And then as you can see here, I already have the AlwaysAI starter apps ready to go. So what I'm going to do is just go into the AlwaysAI starter apps. And then you will see that these are all, are you guys able to see my terminal? No, right? Probably not. All right.
Yeah, you can see it now.
Okay, let me restart this. All right, so once you've downloaded it, you will pull up your terminal, and then you're going to get a you're going to basically write AAI get starter apps. But if you can see, I already have the starter apps downloaded here. So that's just one step that I can't show because I've already downloaded it. But what I would do is I would go into the AlwaysAI starter apps once you've downloaded them. And then as you can see, when you download the starter apps, you have all of these starter apps available to you. So you have the age gender classifier, the face counter, image classifier, the autonomous vehicle, semantic segmentation by NVIDIA, object detector, real-time facial detector, pose estimation, and then various different semantic segmentations. So what I want to do is actually I want to show you the real-time object detector. And when you get into the real-time object detector, what you'll do is in your CLI command line, you take the model you want to use. So you would copy this and paste this into your CLI terminal and then just hit enter. And that will just pull the model right from our directory of models into your starter app for real-time object detector. And then from here, what you want to do from here is go into your favorite IDE. I use Atom. And then I'm going to go into the real-time object detector. Okay, real quick, let's just make sure. So you want to open your object detector in app.py. So this is the main skeleton of your app. So here, as you can see, I have instantiated which type of computer vision model I want to use. So I've specified here that I want to use object detection. And when you go into your, back here, into the model catalog, you want to specify this specific command in your app.py files. So as you can see, I've already done that here, but just to show it, right, we can copy this here and then paste. And then because I'm going to deploy locally, the engine is just going to be my MacBook. But if you were going to deploy this to your Raspberry Pi, you would use engine.dnn.openvino. And then here, let's keep going. Everything looks good. Your accelerator, I'm not using a Movidius neural compute stick, so need not use that. But if you can see here, the cam is also equal to 0 because I'm not using an external camera or a USB camera to support this application. So I'm just going to keep cam as 0. And then results, I'm okay with the results that it's going to give me, whatever it may be. And then I think everything else here looks good. If you wanted to filter the predictions, I can show you how to do that. But for now, I'd say let's just run our app as is, AAI app install. So if you were going to deploy this locally, you want to do AAI app install. So you can see I have this Coco model as well as various other models downloaded, but because I've specified this model here in my app.py, this is the model that's going to run. So after I've done the AAI app install, I'm going to go and do the AAI app start. You just give it a couple moments, and as you can see, basically the CLI command line just specifies for me all of the various things I can identify. So what we're going to do is copy this. No, I don't want to end this. Copy this, and then go into a streamer and then see how it works. All right, so it can identify my plant in the background. It can identify me as a person, and it thinks I'm about 80% a person, but I'm not offended. It's fine, you know, it's all right. But it can identify various other objects too, right? Like, so if I show it my, my phone, and then we can stop the streamer here now. But this is essentially how it works. And when you deploy this to an edge device, this is what the edge device sees. It can start to specify various different things in its area and see how it needs to respond to certain things. So if there's a person that need not be there, for example, a graveyard, and people are loitering, it can start calling the authorities. Thinks my shirt is a backpack, which is a little funny, but I think it's fine. So I'm going to stop this now. And then let's see, there's an error here. Okay, so I just ended this now. Right, so from here, you know, if you want to try different things, try deploying to a drone, try deploying to other edge devices, what you would want to do from here is go to our YouTube channel. So our YouTube channel is full of so much information, right? What is AlwaysAI, getting started with AlwaysAI, installing AlwaysAI on the Linux, on Windows, so on and so forth. These are a couple of videos created by our CEO. And then we have a lot of platform demonstrations. So if you want to have like a detailed walkthrough tutorial of any of these, I would really recommend you check these resources out. They're super helpful. I tried them out when I joined and they were super effective. And I also host a webinar series every month. So if you enjoyed this demo, what I would do is just kind of like look at some of the webinars here and see like if there's any of them that you're interested in. So we had most recently our computer vision on depth cameras for spatial AI. We had computer vision on the edge. So this was object detection, just exactly what I showed you guys. And then how to recognize human activity with pose estimation. So this was the various different like use cases available with pose estimation, such as fall detection, remote physical therapy. And you can try all of them out. These are very detailed tutorials on how you can code out every single application and deploy to your edge device, deploy locally, whatever works for you. And then, you know, these densifies, we also have lots of inspiration available on our blogs. So let's go here. You can take a look at all of these blogs, and you can also search by like a CV service. Maybe you're like interested in object detection or pose estimation specifically. You can go into it, and these are pretty detailed technical articles, sometimes business articles if you're interested, and just get inspired and start building. That's really our goal at the end of this. And then if you're curious about pricing, just really quickly to let you know what this looks like. If you're getting started, it's free to sign up. It's free to go. Like deploying on a single edge device is essentially free. And like we all welcome like hobbyists, the developers, anyone who wants to use the platform. But if you're interested in deploying to more than one edge device, our individual plans start at $29 a month. And then the yearly plan is like $24 a month. Then if you have like an enterprise solution that you're looking at, you can always give us a call or contact me directly. And yeah, we can go from there. But I would definitely take a look at the documents and see how you want to use. So there's so many different like various different application development life cycles you can follow, such as filtering results. You want to do something with object detection. So here, for example, let's get into it. If you want to look at the results and maybe filter the results, you can go from here. And you can use a custom model. So if you're interested in like, maybe you've worked really hard and built your own model, use your custom model, try it out. So that was the live demo. And then from here, just a couple next steps for you guys. I'm gonna have Pramod send you like all of this documentation after this meeting. But if you want to identify a project, what business problem you're trying to solve, how computer vision can help, if you want like help brainstorming a project idea, I'm available for that as well. Like that's one of my favorite things to do. Just like the potential in discussing like how we can go forward from here using computer vision. If you're working on a project already or already using AlwaysAI, let us know how we can help accelerate your project. We're always available on Discord. So the next step is to visit our blogs, how-to guides, and tutorials, and join our Discord community to engage with other developers. And we're launching Always Coding. This is our weekly hacky hour because, you know, like happy hours or so, 2019. We're in 2020, we do hacky hours. But here we go through like very simple setup, you know, no question is like a dumb question. Anyone can come in and ask questions, share your feedback, share your ideas, tell us what you're working on. And it's essentially a very interactive, engaging conversation with the rest of the community, with the AlwaysAI engineers, and just trying to like tell us how we're doing, tell us how you're doing. And if there's any areas you want us to improve on or any areas you're working on and we can help you out with, we're around for that. With that, I'm going to open this up for questions.
All right, thank you, Komal.
Yeah.
That is very interesting. If you want to unshare your presentation, we'll
Sure.
get into the Q&A section. So we do have one question here from Scott. I don't know if you're able to see that, Komal. But essentially he's asking about how many sample images of each kind do you need to train your models? And
Yeah.
do you need to indicate bounding boxes? I don't understand what that is, but you probably do.
Yeah, so to answer your first question in terms of how many sample images for each kind you need to train your model, it's recommended to use as many images as possible to get the most effective results with your model. So I would recommend starting out with like 25 to 50 and like of the same image within various backgrounds. But the more you have, the more effective it will be. To indicate the bounding boxes for each object, yes. So that's essentially how you train your model, and how the computer understands that this is how it works. So typically how it works is you have a training set and then a test set. So you'll train on a specific set of images and then test on a specific set of images to see if it's working effectively. And if it provides you with the results you're happy with, you can move forward and deploy to an edge device. I hope that.
Thank you. Again, if you have questions, yeah, thank you. If you have questions, use the Q&A button, or you can send me a chat, and I'll unmute you so you can ask your question as well. So I do have a couple of questions, Komal, here. So first of all, just looking at the various use cases you had up there and the models. So do you think this is primarily a B2B, as in business to business, model for your company, or are you thinking B2C as well, as individuals?
Yeah, that's a good question. So there's two different doors for it. The first, primarily, we're focused specifically on developers using the platform. So the idea is to just help out as many developers as possible to start getting them to build computer vision applications. And then the second one is working with the B2B group. So working with enterprise customers, working with Qualcomm, the NVIDIAs, or anyone who's really interested in using AlwaysAI to help improve their computer vision process. So it can be both.
Okay.
Question.
Okay, got it. Do you envision some kind of an app store? Because when you talk about the poster detection, that's something that I could use. A lot of people could use that. But I don't know if I really want to build that model myself. But if there is somebody who builds it, I may be able to purchase it or use it. So, something like an iPhone app store. I don't know if you have thought about that or.
Yeah, it's primarily a deployment software right now, and with retraining available, right? So everyone can essentially build the model that they need the most. Making it an app store, that might be in the play for like a future roadmap, but at this point in time, it's primarily a deployment platform.
All right, I have a question here from Pedro, who would like to know what's included in the pricing, any royalties that need to be paid to your company.
Interesting. That's an interesting question in terms of royalties. In terms of pricing, what I can do is let me actually pull up the pricing page again so I can kind of walk through what's going to be included in pricing. Just really quick. All right. All right, so for the individual developer plan, right? So the idea is you have public models available, private models available, and then model retraining available. So if you want to train a model, you would need to have a developer plan. In addition to that, like you get a little bit more support. So as opposed to like an individual developer, you just get support from the community. You get a little bit more internal support. And then if you're working as a team, so say you have a team of individuals who are interested in deploying a computer vision project together. So this could be for your enterprise use case, or like maybe a group of individual developers want to get together and build something. You also have model retraining available. You have premium support available. So that's like the main difference between the individual paying developer and the team paying developers. That you have premium support available. So if there's something you're trying to do and you need help from our internal engineers, we would be happy to help you out under these support plans. And then of course, like if it's just one of you and you want to add a developer, or if you want to add a device, there's additional pricing available. So you feel free to take a look at that as well. Other questions?
All right, thank you. You have a question about possible integrations with what we built using the AlwaysAI platform. So one use case that I spoke about was an individual falling, right? So it's very, very important, for example, in a senior care scenario. But how do you integrate that with possibly some kind of notification to either an emergency department or to a physician, because real-time action is probably required as well based on that feedback.
Yeah, totally. So we actually have an integration available with Twilio. So for example, if you're aware of someone who is living alone and you're concerned about their safety, and you're someone who wants to be informed, or you want to create an app for individuals who want to be informed of someone falling, for example, that integration is available for that specific use case.
Okay. Yeah, if anybody else has a question, please use the Q&A button, or you can post a chat message and I'll unmute your phone. I have one more question, a little bit controversial question. This is an area that I've been very interested in, which is the whole concept of bias, generally speaking, with respect to AI. And when I talk about computer vision, of course, one of the use cases that I think you probably said that is in criminal justice, right? Identifying potential people who can do potential harm, right? So what are your thoughts on that? I mean, in terms of bias kind of creeping into that modeling because of the data that you feed into the model potentially has a bias already.
Yeah, my personal opinion on that is that in terms of criminal justice, it should not just be led by algorithms. I think that algorithms should be there to support humans running those kinds of investigations as opposed to simply guided by algorithms. I'm not sure if the world's ready for that. Thinking in terms of bias. So in an effort to eliminate bias, it's all about how you train your model, right? If you're looking at a coffee cup, for example, you want to be able to identify that coffee cup in various different backgrounds, in various different lighting. And that training data set that you use to build your model is going to be the greatest indicator of what kind of bias or what's missing or what's too available in that data set that ultimately determines the predictive model that's created at the end. So for example, if you noticed when I did the demo, it thought that my shirt was a backpack, and well, that's kind of like a very innocent mistake, but if this was applied in like a criminal justice kind of situation, I don't think that would be the best place to use it. But for cases of saving someone, I think super effective, right? Like with it being an edge-based platform, the idea is that it's very network independent, right? So I wonder if I didn't get that piece here. So yeah, maybe it wasn't a part of it, but the idea is that with it being an edge-based platform, an edge device can go and operate somewhere entirely network independent. So you need not be connected to a specific network or a internet service provider in order to run your use case. So in those instances, it's really valuable to have something running on the edge. So some of the examples I described earlier were rescue drones that save hikers in the Pacific Coast Trail, or rescue drones that go out in the ocean to save swimmers in like the night sky, or surfers in the night sky. These are places, or agriculture, right? Like you want to be able to have these tools working even when there is no internet service or where internet service is underserved. The second point of edge is that it's more quick to respond. So instead of going through this loop of hey, I have this thing that I've identified, and now you have to send it to the web and have the cloud do the inferencing and then send an output variable, that can take more time than just the edge device responding in and of itself, right, immediately. And the third piece is cost. Cloud companies charge per inference or by the hour, depending on how frequently you're running your computer vision model. So if you were to use it for a train station that's running 24 hours a day, that cost could add up to hundreds of thousands of dollars over the course of 3, 4, 5 years, right? Whereas on the edge, you're just paying for that initial investment of the edge device, as well as software that shares those models or sends those models to an edge device. Does that make sense, right? Like,
yeah, that makes sense. I think that reminds me of voice recognition on your phone, which I don't think it goes to the network either, because that's kind of pushed out doing software updates. I think it's a similar strategy here. Okay, let me see if there's another question.
Yeah, and
another question from Scott.
Oh, sorry, go ahead.
So the question is asking is for an edge device, say in NVIDIA Jetson Nano, what kind of limits have you seen in the number of objects that you can reasonably classify?
Yeah, I don't think the limit is necessarily in the number of objects it can identify, but I would say it's more so in the frames per second, depending on which edge device you use. So to give you an example, if you were to use a Raspberry Pi, just a Raspberry Pi alone, that frames per second is going to be way slower than if you were to use a Raspberry Pi with an accelerator like a Movidius Intel neural compute stick, right? So when you take a Raspberry Pi with an accelerator, it performs much faster. But if you were to move from a Raspberry Pi to a NVIDIA Jetson Nano, that frames per second goes up a little bit more, right? So the limitation, I wouldn't say, is in the number of objects necessarily, and there are ways to like filter out results too. So if you want to like filter the labels to only identify a person, or if you want to filter the labels to only identify plastic bottles, glass bottles, things of that nature, you can do that, and like that way you can clear out the noise. But I wouldn't say the limitation is, again, in the number of objects. It's more so in the speed at which it can identify those things.
Okay. Thank you. I don't see any other questions coming in. So again, I want to remind you of next week's meetup. It's going to be on Apache Kylin. It's a new analytical data warehouse platform for big data. So we are kind of switching back and forth between AI and big data here, which is a good thing. And Sushma Pulluri will be hosting that meetup. I see that she's online. So thank you, Komal. We really appreciate you coming and sharing your insights and information about your company. I'll certainly post all the links that you're going to send me. And this recording will also be available. So thank you very much. You know, it's all about sharing what you know and then learning from each other. That's what this meetup is about.